Okay, in this video, this is just a addendum of the video that I did on logarithmic functions. And one of the examples, I think I didn't clarify how I did that problem correctly, so I do need to go ahead and clear that up with you. Like in this problem, we had log to the base 36 of 6. So basically, with logarithms, you're just trying to find out what that missing exponent is. In other words, you want to find out 36 to what power would give you an answer of 6. Okay, now what I'm going to do here is work backwards to come up with that exponent for the number 36. Now, using 6, I know the fact that 6 to the second power gives me an answer of 36, because 6 times 6 does give us 36. Now here's what I'm going to do here. I'm going to turn that 6 to the second into 6 to the power of 1. And to do that, I have an exponent of 2. Now, if I take the reciprocal of 2, that's going to give me 1/2. So what I'm going to do here, add 6 to the second, and I'm going to raise both sides of this equation to the power of 1/2. Okay, because I have 6 squared raised to the 1/2, and then 36 raised to the 1/2. Well, there's a rule that says if you raise a power to a power, you're going to multiply your exponent. So here, we're going to do 2 times 1/2, or you can think of 1/2 of 2, which will be 1. So that'll be 6 to the 1, which will just be 6. And that's equal to, now bring down 36 to the 1/2. Okay? Now I can see what my missing exponent is, because of the fact that 36 to the 1/2 gives me 6, so that means that that missing exponent is simply 1/2. So log to the base 6 of 36 would be 1/2. Another example would be log to the base 64 of 8. In other words, 64 to what power would give me the answer of 8. So again, we're finding the missing exponent. I know for a fact that 8 to the second, which is 8 times 8, that gives me 64. Okay? Now I'm going to do this the same way that I did the last example. Make that 8 to the second, 8 to the first power. The reciprocal of 2 is, again, 1/2. So I'm going to take 8 to the second, raise it to the 1/2, and then I'm going to do 64, raise that to the 1/2. Now, 8 to the 2 raised to the 1/2, which means we raise a power to a power, we multiply the exponent, so 2 times 1/2 will be 1, so this will be just 8. Then now bring down equal 64 to the 1/2. Okay, so in this case here, my missing exponent in this case will be 1/2, which means 8 is equal to 64 to the 1/2, so that means that the missing exponent for 64 would be 1/2. Okay, those are just a couple of simple examples. Let's look at a couple of more that are a little bit more complicated, like log to the base 32 of 2. In other words, we're finding the missing exponent here, so 32 to what power would give us an answer of 2. Okay? Now, I know this. 2 to the 5th would give me 32. Now, if you didn't know that, you can take that 32, divide by 2, and you can just continue dividing by 2 until you get all the way to the end. As you can see, 2 is used as a factor 5 times, so 2 to the 5th power would be 32. Now I'm going to make 2 to the 5th 2 to the power of 1. Now, it's raised to the 5th power, so the reciprocal of 5 would be 1 over 5. So let's raise both sides of this equation to the 1/5 power. And then on the left side, to raise the power to a power, you multiply your exponent. So 5 times a fifth will be 1. So this will be a 2. Then I'll bring down 32 to the 1/5. And that 1/5 becomes your missing exponent right here. So that missing exponent is 1/5. So I can conclude that log to the base 32 of 2 will be 1/5. And then finally, log to the base 27 of 3. Again, we're finding the missing exponent. That means that 27 to what power will give you an answer of 3. Okay? Now, I know 3 to the third is 27. Because in this case here, if you keep dividing by 3, you'll see that 3 is used as a factor 3 times. Now, I'm going to make that 3 to the third, 3 to the first power. The reciprocal of this 3 is 1/3, so let's raise both sides of that equation to the 1/3. And 27 will be raised to the 1/3. Now here we're raising a power to a power. We multiply the exponents here. So 3 times the third is going to be 1. So that base will be 3. That's equal to 27 to the 1/3. I didn't need the parentheses here, but that's not necessary. Now that 1/3, that's your exponent for the 27. So we can say that log to the base 27 of 3 would be 1/3. Okay?